All right, for this worksheet, if you have a printer, you'll see on the next slide, I really do think it's going to make your life easier if you can print this out and try it. Otherwise, there's PDF editors, or you can just make sketches in your notebook. I wanted to go over a couple of the problems, just how I would think about it, how I'd approach it. For number 1, you're still working with most of the same information with slope-intercept form. I have a y-intercept. I know it's a negative line, so I know initially that it's heading downhill. And since it's greater than or equal to, I know it's going to be a solid line. So I think of that slope as -3/1. I'm going to drop 3, run 1. There's a point. Drop 3, run 1 again. I'll keep going to make sure it's a nice, neat picture. From there, since it's a solid line, I'll draw that solid line, arrows on the end. And now all we really have to figure out is which side we're going to shade. So one thing that you could do, we've said you could select ordered pairs and test them. So I might pick something that's really easy to work with, like 0, 0. If I plug in 0 here and here, I'm saying that 0 is greater than or equal to -3 times 0 is 0, plus 4 is 4. 0 is not greater than or equal to 4, so I'm going to end up shading this side of the graph. Some people are really good at just figuring out greater than, that's above, this side's above the line. If you don't see it that way, if you're struggling, make sure you test a point, make your life easy, pick something like 0, 0, pick something like 5, 5 that's just easy to work with, and see if it's true or not. Another problem that I'd like to go over is something like number 4, which I'm sure some people will struggle with. When we see something, so I'm just going to make it an equation for a second. When we see equations like this, y equals 4, hopefully we've gotten to the point where we know it's strange behavior. We know it's going to be a horizontal or a vertical line, and we're just trying to figure out which it is. Make that negative. When it says y equals -4, we have 2 ways of thinking about it. I know that this is going to have ordered pairs where y is always -4. So I might just make up a couple where that's true. I'll point at 1, -4, 5, -4. I'll plot those points and connect them. The other kind of shortcut, if I find -4 on my y-axis and draw a line so that I can see it, that's all we have to do. I'm going to erase that real quick, because one thing we want to always look out for, since it doesn't have that or equals to, my boundary line is going to be a dashed line. It's pretty much saying that these points, should be a little higher up, are not included, but everything else in the shaded region is. I still have arrows. That boundary line continues forever. Since y is anything greater than -4, all of these y values work. So I'd shade this entire upper half. The only other problem type I wanted to go over before you get started on your own is something where you have to convert to slope-intercept form. For something like number 9, my goal is going to be to isolate y, so I would start by subtracting that x term. When I subtract 3x from both sides, I'll be looking at -3x plus 10. I still have that less than, and I have a -2y. So I subtracted 3x from both sides. What you really need to be careful of, my next step where I divide by -2 on both sides, a couple things. This will cancel. That's not too bad. We're left with y. But when we're dividing by a negative, the inequality symbol flips. So that's something you probably haven't dealt with in a while. It's something to be really, really careful of with these inequalities, because that's going to make your solution set, that shaded region, look completely different. -3 over -2, a negative divided by a negative becomes a positive, so I'll simplify. I have x, and then 10 divided by -2, -5. So the graphing's not that different. Rise 3, run 2. I know it's a dashed line. Since it's greater than, I would shade that region.